Hello students, I am Deboina Bhomik from Techno India Group Public School. Today I'll start a new chapter called Coordinate Geometry. Our today's topic is Introduction of Coordinate Geometry and Distance Formula. You know about the coordinate geometry. You have learned about this coordinate geometry in class 9. Okay, so let us start the discussion. As you can see, this plane is called Cartesian plane. Okay, this horizontal axis is called x-axis. Okay, and this vertical axis is called y-axis. This one is y-axis, and this x-axis and y-axis divide this whole Cartesian plane in 4 quadrants. Okay, this one is first quadrant. Okay, this one is first quadrant, this one is second quadrant, this one is third, and this one is fourth quadrant. Okay, now in first quadrant the value of x and the value of y both greater than 0, that is such as 1 2 2 3 5 6, okay, or 9900 in such way, or 5 11. Okay, in the second quadrant the value of x is negative but the value of y is positive, such as -3 1, okay, then -2 4. In third quadrant the value of x and the value of y both are negative, such as -3 -1 or -5 -7. In fourth quadrant the value of x is positive but the value of y is negative, such as 3 -1 or 2 -5. Okay, so these 4 are called quadrants. This is first, second, third and fourth quadrant. Now if this one is our Cartesian plane, then this point is called origin. Okay, this point is called origin. I have discussed about the x-axis and y-axis in the previous slide. Okay, this horizontal one is x-axis, vertical one is y-axis, and as you can see, here is a point and the coordinate of this point is marked as 20, 15. So the distance of a point from the y-axis is called x-coordinate or FC sub, and the coordinate of the point, the distance of the point from x-axis is called y-coordinate. That means if you take this point A, okay, as you can see the coordinate is given as 20, 15. Okay, if you look at the point, from point draw a perpendicular over x-axis and y-axis. Okay, now you can say that the distance of this point A, the distance of this point A from y-axis, okay, what I said, the distance of the point A from y-axis, I am marking this one as AB. Okay, the distance of AB will be 20, this 5, 10, 15, 20. That means the distance from the y-axis is called x-coordinate. That's why here x-coordinate is 20. Okay, so let me explain this one again. What I said, if you take this point and draw two perpendicular line to y-axis and x-axis, mark this was as B and this one is C, you can say that the distance of A point from y-axis is 20, okay, and the distance of A point from x-axis is 15. Okay, this one is same as this one, so this one is 15. So that's why the x-coordinate is 20 and the y-coordinate is 15. So what is x-coordinate? X-coordinate is the distance of the point from y-axis, and y-coordinate is distance of the point from x-axis. Now any point on x-axis is marked as x, 0. Okay, such as if I take this point this point on x-axis, this one will be marked as 10, 0. If you take this point, it will be 35, 0. If you take this point, it will be minus 20, 0. Okay, and if you take any point from y-axis, it will be in the form of 0, y, such as if you take this point, it will be 0, 20. Okay, if you take this point, it will be 0, minus 15. So any point on x-axis is of the form x, 0. Any point on y-axis is of the form 0, y. And the coordinate of any point on any quadrant is of the form of x, y, such as point A. Okay. Now we will discuss about the distance formula. Suppose there is 2 points x1, y1 and x2, y2. Suppose there are 2 points whose coordinate is x1, y1 and x1, x2, y2. Now what will be the distance between these 2 points? This green line is the distance between these 2 points. Okay, so the distance between these 2 points will be d is equal to root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so what is the distance formula? Root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so how can I evaluate this formula? Okay, let us find the distance between any 2 points P given as whose coordinate is x1, y1 and Q whose coordinate is x2, y2. Okay, so this is P point. Okay, and this one is marked as Q point. From P and Q, draw the perpendicular PR and QS on the x-axis. These two are perpendicular on x-axis. Now the coordinate of P point is given as x1, y1 and Q point is x2 minus y2. That means you can say that the value of RS will be x2 minus x1. Okay, so the value of RS is x2 minus x1. Why? Because this OR is x1. Okay, and this OS is x2. So that's why RS is x2 minus x1. Similarly, if you discuss about the value QT, okay, about the value QT, as you can see, SQ is equals to Y2. Okay, SQ is equal to Y2 and ST is equal to Y1. Okay, ST is equal to Y1. Why? Because ST and PR both are same. Since PR is equal to Y1, ST is also Y1. Therefore, QT will be Y2 minus Y1. Now, if you look at the triangle, QTP, if you look at QTP triangle, QTP is a right angle triangle. So you can use Pythagoras theorem here. Okay, and by Pythagoras theorem, it will become PQ square is equal to PT square plus QT square. Okay, in place of PT and QT, put the value x2 minus x1 and y2 minus y1. Okay, so it will be in this way. That means PQ is equal to root under x2 minus x1 whole square plus y2 minus y1 whole square. This formula is called as distance formula. Okay, so you just have to remember what is the distance formula. No need to remember this proof. Okay, now I have to apply this distance formula in a regular problem. Find the distance between 2 points. A is given as minus 4, minus 1 and B is given as 1, 2. The coordinate of A and B are given. You have to find the distance between them. Suppose this is A point, this is B point, coordinate is already given. What will be the distance? That is AB. Distance is defined as d and the formula is root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, here I am considering this one as x1, y1 and this one as x2 comma y2. Okay, so if you apply the formula x2 minus x1 whole square, that is 1 minus of minus 4 whole square. Okay, and y2 minus y1 whole square means 2 minus of minus 1 whole square. Okay, so the distance formula will be root under of 1 minus of minus 4 whole square plus 2 minus of minus 1 whole square. Now do the calculation. The distance will be root under 34 unit. Okay, now another application. Do the point 3, 2, minus 2, minus 3, 2, 3 form a triangle? If so, name the type of the triangle. Okay, now the point is given as, suppose I am considering the point as P, Q, R. Suppose P is 3, 2, Q is minus 2, minus 3, R is 2, 3. So if you consider this triangle as P, Q, R, okay, so I can find the coordinate of PQR is given, so I can find the length of the side PQ, PR, PR and QR. Okay, so first of all let me find the distance PQ. This is P coordinate, this is Q coordinate. If I apply the distance formula, it will be 3 minus of minus 2, that's why 3 plus 2 whole square, 2 minus of minus 3, that is 2 plus 3 whole square. So it will be root under 50. Similarly, we can find the distance between Q, R. This is Q, this is R. Okay, so it will be minus 2 whole square, root under minus 2 whole square plus minus 3 whole square. If you do the calculation, the value will be root under 52. Now find the distance between P, R. The value of P is given as, coordinate of P is given as 3, 2 and coordinate of R is given as 2, 3. If you apply the distance formula, it will become root 2. Okay, so as you can see, if you do the square, okay, let me explain this one again. If you do the square of this one and square of this one, so if you do the square of this one, it will become 50. If you do the square of this one, it will become 2. So, and if you add this 50 and 2, you will get 52. Okay, you will get 52, which is equal to the square of this one. That means you can say that PQ square plus PR square is equals to QR square. Okay, since the sum of any two these of distance is greater than the third distance, therefore PQR form a triangle formula. Okay, so PQR form a triangle. Again, the sum of square of two sides is equal to third side. So by the converse of Pythagoras theorem, you can say that this P angle is 90 degree, that's why PQR is a right angle triangle. In the converse Pythagoras theorem, it is given that the angle opposite to the largest side, the angle opposite to the largest side will be 90 degrees. Suppose this is PQR triangle, PQR triangle. From this equation, it is clear that QR is the largest side and QR square is equal to PQ square plus PR square. Okay, that means one side square is equal to sum of two other side square. So that means by converse Pythagoras theorem, the opposite angle of PR, that is P, will be 90 degree. Okay, that's why P is 90 degree and PQR is a right angle triangle. Now let us check the next example. Next question is, show that the point 1, 7, 4, 2, minus 1, and minus 4, 4 are the vertices of the square. You know that for a square, the four sides are equal in length, and the length of the diagonal is also equal. So suppose I am considering a square. Okay, suppose this is a square A, B, C, D. Okay, A, B, C, D. Okay, now for square the distance have to be equal, right? So I am considering the vertices as A, B, C, D. Now I will find the length of each side. The length of AB, take these two coordinate and apply distance formula, you will get the value of AB, right? Now for BC, take these two and apply the distance formula, you will find the distance between BC. Take this C and D and apply the distance formula. You will get the value of CD length. Take this A and take this D. You will get the value of AD distance. Okay, so as you can see, the value of AB, BC, CD, AD. Okay, the value of these four sides is same and it is root under 34. Now I will find the value of diagonal, the length of diagonal. For diagonal, you have to measure the distance between A and C, right? You have to find the distance between A and C. So take the point A and C and find the distance between them. This is A, this is C, and use the distance formula. The value will be root under 68. Similarly, you can find the value of BD. Okay, take B and D and use distance formula. The distance between BD will be root under 68. As you can see, the length of the diagonal is also equal. So since the sides are equal in length and the diagonals is also equal to each other, so you can say that this quadrilateral will be R square. In this way, you have to find you have to solve this question. Okay, now this example. Find a relation between x and y such that the point xy is equidistant from the point 7, 1 and 3, 5. Okay, suppose I am considering this 7, 1 and 3, 5 as the point A and B. Okay, and I am considering this xy point as P. Okay, these are the 3 points. It is given that this P point is equidistant from A and B. That means AP distance is equal to PB distance. Okay, AP distance is equal to PB distance. Do the square on the both sides. That is AP square is equals to BP square. Okay, now take this A point and P point. Okay, and use the distance formula between them. Then you will get AP. Since I am doing the AP square here, so the root under will be not there because I am applying square on the both sides. Okay, so AP distance will become x minus 7 whole square plus y minus 1 whole square. Okay, and if you find the value of BP, take this B and this P. Okay, what will be BP? BP will be root under x minus 3 whole square plus y minus 5 whole square. So that implies BP square will be, since I am applying the square on the both sides, here will be x minus 3 whole square plus y minus 5 whole square. Okay, this term. Now to apply the A minus B whole square formula on the both sides. As you can see, this x square will cancel to each other, y square will cancel to each other, and if you do the subtraction and addition on the both sides, you will get x minus y is equal to 2, which is the required relation between x and y. Okay, in this way you have to find what is the relation between x and y. Okay, in this way you have to solve this one. Now question number 5. Find the point on y-axis which is equidistant from the point A and B. Again, suppose this one is any point from y-axis. Suppose I am considering this one as P. Here is A and here is B. Okay, the coordinate of A and B is given. Now it is given that this P is equidistant from A and B. That means you know that AP is equals to BP. Now also given that this P is from y-axis, and I told you any point on y-axis can be written as 0, y. Okay, so I am considering, since I don't know what is the coordinate of P and I only know that it is on y-axis, so I am considering the coordinate of P is 0, y. Okay, now since it is equidistant from A and B, so I can write AP is equal to BP. Okay, or you can write AP square is equals to BP square. Okay, now apply the formula. Okay, if you take this P coordinate and A coordinate, okay, if you take P and A coordinate, the distance of AP will be 6 minus 0 whole square plus 5 minus y whole square. There will be a root also. Okay, and if you take this BP will be same root under minus 4 minus 0 whole square plus 3 minus y whole square. Okay, so since AP square is equal to BP square given here, okay, since AP square equal to BP square is given here, so after doing the square on the both side, in the left hand side it will be 6 minus 0 whole square plus 5 minus y whole square. In the right hand side it will be 4 minus 0 whole square plus 3 minus y whole square. Okay, now apply the a minus b whole square formula on the both side. You will get the value of y as minus 9. So the required point will be 0, 9. Okay, and so you can check our solution is right or wrong. Okay, if you find the distance, this is our required P point, you can find the distance AP and BP, and you can check that the both value, the both length will be root under 52. That means our answer is correct. Okay, in this way you have to solve this one. So this is all for today. Thank you.